Dina, and welcome everyone to today's webinar, Building and Implementing an FRAR Program for the Arc Flash Hazard. I'm Ed Rutkowski, Editor-in-Chief of The Synergist, a magazine of the American Industrial Hygiene Association. Very happy to be here today for the first Synergist webinar of 2018. I'd like to thank all of our listeners for attending today's event, and especially Bulwark Protective Apparel for sponsoring this webinar. Our presenter today is Derek Sang, Technical Training Manager at Bulwark. Derek has been involved with the flame-resistant clothing industry in a variety of roles from the service, manufacturing, and garment sides of the business for over 20 years. He has developed and conducted over 250 educational and informational seminars on the hazards of arc flash and flash fire. In his current position as a technical training manager, Derek has developed over 40 hours of training curriculum for Bulwark University. These training efforts cover all aspects of FR clothing, helping companies to properly design and implement an FR clothing program and comply with OSHA training requirements for PPE. Now, Derek, I'll turn the presentation over to you.
Thank you for the kind introduction, Ed, and good morning or good afternoon to those who are taking in the webinar live today. Certainly appreciate you taking your valuable time to spend it with us for this short moment. Just real quick, obviously, from a disclaimer standpoint in this short informational webinar, customers, you're responsible for doing your own hazard risk assessments, and then obviously selecting the appropriate PPE as needed. So disclaimer out of the way, let's get started. So building and implementing an FR, flame-resistant, AR, arc-rated program for the arc flash hazard. That's a big, broad subject, and we're going to spend about 45 minutes a day just touching the tip of the iceberg on this, and hopefully just digging in a little bit to give you some takeaways. So just for quick review, what is flame-resistant arc-rated clothing? So we still call it flame-resistant, we still call it arc-rated because all arc-rated clothing is flame-resistant. Not all flame-resistant clothing is arc-rated. Once you're flame resistant, you have to go in and take additional testing, like additional qualifications, in order to be labeled arc rated. For the arc flash hazard, it demands that your garments have to have proven themselves in that hazard, so they get labeled arc rated. But they still live within the big umbrella of flame resistant clothing, so hence the acronym. Why do we need flame-resistant arc-rated clothing? Because non-flame-resistant clothing will ignite and continue to burn, resulting in severe burn energies that ultimately can lead to fatalities. Remember, arc flashes or our other hazard for flame-resistant clothing, flash fires, in and of themselves are so short in duration, short enough in intensity that as themselves cannot lead to fatality. It's the clothing igniting and continuing to burn that ultimately causes catastrophic body burn and will lead to that fatal outcome. So anything we can do to drive body burn down and mitigate injury where we can, we want to do. And that's where your flame-resistant arc-rated clothing comes in. It is made from fabrics, by definition, that put themselves out. You're well aware that these are nasty, nasty events. When we set off arc flashes, we superheat air from an ambient air temperature of, say, 70 degrees all the way to tens of thousands of degrees in literally a blink of an eye. We've created a bomb. With a bomb, we get a whole bunch of other nasty things. All we're protecting you against is clothing ignition. By interrupting clothing ignition, the event only lasts as long as the event does. We're not continuing the event artificially by having clothing ignition. We're minimizing the injury because we're putting ourselves out, and we're taking something that potentially could have been fatal and taking that off the table. Your survival, the extent of your injuries, your recovery time, everything depends on the quality of your FRAR clothing and that you've properly implemented it at the time of the event, and we'll talk a little bit about that further. When we're educating our end user community, we need to make them understand a couple things. The first thing they need to understand is we live in the secondary protective clothing world. Well, if you have secondary, what's primary? Well, primary is real easy. Most people get the analogy real quick when I say a firefighter. Firefighter rolls up to a structural fire, gets off his big red truck, and he has his primary PPE on. He has his bunker gear jacket, his bunker gear pants, special gloves, really cool hard hat, most importantly, his breathing apparatus, and now he voluntarily walks into a thermal event. When that fire is put out and they return back to the station house, he gets to take all that PPE off. Because why? It's task-based. He wears it when he is knowingly going into a thermal event, primary. In our world, secondary, these are accidental. We don't design electrical equipment to blow up. We don't design oil and gas facilities and vapors and dust to explode when we're working. So because they're accidental, we don't know when they're going to happen. So the only way to have it on when we need it is to be wearing it all the time. So secondary protective PPE, daily wear. We are going to have at least a certain level of protection at all times in our work environment. We also want to understand the hierarchy of safety. PPE is our last line of defense. These 7-ounce shirts and these 12-ounce jeans or whatever your fabric weight and configuration is don't make you Superman. You're not impervious to injury. We want to follow the safety hierarchy always. We want to eliminate it if we can, substitute it if we can, engineer it out, and if we have to put people in place, we want to have enough sign-offs and check-offs why we're putting a human being in harm's way, and then we want to make sure that they're trained and wearing their PPE appropriately if they do have to go into harm's way. But as it shows you on the pyramid, it is your last line of defense. Think about it this way. In our automotive environment, we've probably seen more innovation, more cool safety engineering in the last 10 years than all the previous years combined. I mean, think about it. You see this little smart car toting around this giant SUV. That shell, that titanium shell, has been engineered to provide protection to those occupants traveling in and amongst these giants. We have airbags, believe it or not. That tiny little smart car has 8 airbags in it. You know, God forbid if they all go off at the same time, but it has 8 airbags engineered to protect you. We also have side view mirrors today that will audibly acknowledge or at least visually let you know there's something hiding in your blind spot. Some of them today, you can't even change lanes if it recognizes there's something in your blind spot. We've seen cars now that can park boats, parallel park, and if you're not quick enough to stomp on the brake, it will stop for you. That's all engineering. Think about all that. Then why do we still rely on 70-year-old technology? It's got to be obsolete by now, doesn't it? That is a proven life-saving piece of equipment. When all your engineering fails, when everything does not work, it stops you from going through that windshield. No matter how bad it is on this side of the windshield, it's better than 25 feet down that asphalt. Ask any highway patrol officer's survival rates of ejection accidents. They're virtually nil. Your last line of defense in an arc flash is your clothing. That is your safety belt. But you have to have it on, and it has to be worn correctly in order to work. I used to share a number of articles throughout our presentations for years, and finally we just stopped doing it because, one, they were too numerous, and two, they were kind of a little bit of overkill. But there's still one article that in 2 quick paragraphs explains why I do what I do for as long as I've been doing it. In 2004, we have an electrical incident in a school in a suburb of Chicago. Well, 2004 is 4 years after NFPA 70E came out and said, hey, wear FR clothing when you're working on energized electrical equipment. And I'm extremely paraphrasing there. The second paragraph is the Cook County Medical Examiner. The medical examiner is the coroner, ladies and gentlemen. You never want the coroner talking about you. There was a spark igniting this electrician's clothing, which caused him to perish in the hospital from those injuries. If it had been arc-rated clothing that he was wearing that day as opposed to clothing that caught fire, we wouldn't be talking about him in the past tense. That is the reality of it. FR, flame-resistant, AR, arc-rated clothing is your last line of defense, but if it's used, it will save your life. So how have we addressed these in our regulations and standards? Well, the biggest regulation that we always go to is we look at 1910-269 for our utility workers. Well, for many years, in the early 70s, we didn't mandate FR/AR clothing. We just said don't wear clothing that will add to the injury. We got a little bit more refined in 94, but still no mandate for FR/AR clothing. We said don't wear meltables such as polyester, rayons, and nylons. That's common sense, but they allowed for natural fibers, cotton. Really? Cotton's a fuel. Give it enough heat and it will ignite. So we moved on from there, and then 20 years after that fact, back in 2014, we finally mandated that we have flame-resistant, now arc-rated clothing equal to or greater to than a reasonable estimate of the incident energy that electrical worker could be exposed to. This long overdue update to this law is estimated about saving 20 lives a year and 118 serious injuries. On our low voltage side, general industry inside our buildings, away from the power generation, transmission, distribution, and metering. Inside the building now, NFPA 7E. NFPA 7E primarily was written to make sure that you do an arc flash risk assessment of your facilities. What does that risk assessment generate at the end of it? It generates a little sticker. That sticker says the incident energy or the category of protection needed working on this piece of equipment, if it fails, is X. We basically tell electrical workers how big a bomb they're standing in front of so that they can dress accordingly. So that quick summary is, as we all well know, OSHA is the shall. OSHA says you shall protect your people, you shall do these things. Where do we turn to as safety professionals as far as the how? The how is our standards. Whether it's our ASTM standards, our ANSI standards, our NFPA standards, as safety folks, that's our playbook. That's what we go to ultimately comply with the regulation. So you have an arc flash hazard. Now what? Well, you've done a reasonable estimate of your incident energies on the utility side, or you've actually done your arc flash risk assessment on the 70E side. And what have you found out? You've found out in most cases a large majority of your equipment is going to be less than 8 calories of incident energy. That means if that piece of equipment fails, it's going to produce less than 8 calories of incident energy. So what's the default been for years now? 8 calories or more protection in a arc-rated shirt and pant. The default is Cat 2. PPE Category 2 for 70E terminology, 8 cals or greater on our utility side, and we found that for the most part, that's the large majority of what we do. So what happens when we do this reasonable estimate on the utility side and we do our arc flash assessment on the 70E side and we find out we've got pieces of equipment in there that we need more than 8 calories of protection? Well, on the 70E side, we see that we've got switching gear, we've got big MCCs, we have on the utility side, we have our substations, our power generation, where a lot of these higher incident energies are. What do we do? Well, there's a couple things you can do. One is you can get further away. Remember, most of these default calculations are done primarily at about 18 inches. Why 18 inches? That's the distance between my chest and the energized electrical equipment, approximately. And that's the default distance for the large majority of calculations. That being said, what can I do then? Well, I can get further away. I can operate it remotely. I can operate it at the end of a hot stick. I can operate it to where whatever I need to do, I'm not in front of that piece of equipment. I've created engineering to where I can access it and not be exposed. That all sounds great, and it can work some of the time, but sometimes we have to be hands-on. So if we have to be hands-on, then what can we do? Well, we have to layer up. And in layering up, we can get a couple of, we can eliminate a couple of things. We can get some advantages. We can make working a little bit easier. So let's talk about what happens in an arc flash. And just here, over the next few pictures, you'll see, here's meters. We had an arc flash incident. We had an electrical worker. Here's his PPE. You can see where the energy came from. Came all down the right side here. You can see his rubber gloves, his leather protectors. Those were his safety glasses. Here's one of the things that are telling. When we look at this, this is his undergarment. Now, are we allowed to wear 100% cotton underneath our FR arc-rated clothing? Absolutely. Cotton, silk, wool, natural fibers can be worn underneath our outer layer, which in this case would be our shirt. So our shirt here, we can wear cotton underneath, silk underneath, a wool underneath, or wear nothing underneath. We don't want to be wearing meltables, so this is fine. All the standards say, yeah, there's nothing wrong here. But obviously we can see from this visual that there is a lot going on here, and it can be very wrong. That's charring. That's the precursor to what? That means there's just, luckily in this case, there wasn't enough energy to ignite that non-FR lightweight, in this case, undergarment. So what could have happened? Well, if it ignited, you're going to have a cotton fire underneath your FR arc-rated clothing. So how do we deal with that? Well, first of all, they tell you no meltables. We don't want any meltables. Okay, that makes sense because you just saw all that energy went somewhere. All that energy, that outer layer does not stop energy. Okay, it doesn't stop IR. It doesn't stop forms of heat getting through that fabric. So we don't want any meltables underneath there. Secondly, two lightweight layers, if they're both happen to have flame-resistant arc-rated properties, can be much more protective than a single heavier layer. So let's look at that a little bit. So why do we talk about it, especially when it comes to our arc flash hazard? In our arc flash hazard break open, that lower picture there is very real. Remember, we're making a reasonable estimate of that incident energy for our utilities. We've done a hazard assessment for our 70E folks, and remember, what's the default distance? 18 inches. What if I get a little bit closer? What if it doesn't trip as fast as the calculations say it would? Stays open a little bit longer. I'm exposed to a little bit more energy. What happens to that reasonable estimate of that incident energy? Is it going up? Absolutely. Can I overwhelm that outermost layer? Yes, you definitely can. So as that outer layer starts to fail, what is underneath now becomes very important. As you see in that upper picture, that unfortunately is an electrical worker who was not properly trained on what he could wear underneath, or he chose to ignore his training and what he wore underneath. His outer layer did exactly what it was supposed to do. It self-extinguished. All that additional heat passed right through there and hit that lightweight 100% performance polyester and melted it to his skin. Remember also, you get concussive force with those arc flashes. What do you think happened to that melting plastic when 2,200 square foot pounds of concussive force followed up after it melted? Well, it drove it into his skin. That's the scarring that he has to live with because of that arc flash incident that he ended up going through. So what we wear underneath is very important. And if we experience break open, now it comes to factoring into whether or not I could be hurt more than I should be. And then the last thing is who are we going to employ to police our undergarments? How many of you have seen white cotton V's on your employees as you walk down the line? They're all wearing their arc-rated shirts. You see that little white cotton V sticking out the neck. Are you 100% confident that those are 100% cotton every single time? Are you 100% comfortable that there's not a big old logo hidden underneath there that you can't see? So who are you going to have go through and check that that white cotton is not 80-20, 50-50, 65-35? Who's going to be checking that there's no big logos on there? Going to arc-rated base layers will help eliminating the need to police some of those undergarment issues. Now, regardless of arc flash or flash fire, when discussing undergarments, only natural fibers are allowed per the standards. And remember, standards are our minimum baseline. We can always do better than the standards. Layering of non-melting flammable garments is permitted. That means you can have cotton underneath my FR arc-rated outer layer, absolutely, but you have to ensure that that outer layer is sufficient to prevent break open. So in that reasonable estimate of that incident energy, you need to have not just a little bit more, you need to probably have a significant amount more so that it does not break open. Or you need to know where the break open is so that you're comfortable you're not exposing a ignitable underlayer to any leftover energy. Only arc-rated FR layers within the layer system are used to determine that system's arc rating. Arc ratings of individual layers cannot simply be added together. That's a long-winded way of saying we have to test them as they're going to be worn to know what that system is. And ultimately, at the end of the day, you have to know that if you're going to incorporate it for higher incident energies. Now, all our standards when it comes to arc flash, 1506 and 70E, understand that we are going to have electrical workers in and around energized equipment where they may be exposed to higher energies. And it even talks to that layering of arc-rated garments can add to the protection. So we've acknowledged that both in ASTM 1506 and also in Annex M in NFPA 70E, we talk about layering and what needs to be done. The important thing to understand in both those discussions is those systems have to be tested. We have to know how they'll perform together. So why is that? Why have we taken something to where now if I have an 8 in my shirt and a 6 in my base layer, why can't I just say I'm just a 14? Why can't it be that easy? Well, believe it or not, back in the day, and by going back in the day, I mean in the mid-90s, we could say that. Why? Because we had a very limited selection of fabrics. We had Nomex 3A, we had Kermel, we had PBI Kevlar, we had Endura Ultra Soft, and maybe one more there. And we knew how they all interacted with each other. We had about 20 years experience with these limited fabric options. Nowadays, how many fabric options do we have? We don't know how they all interrelate with their different mix of fibers and their different mix of FR and non-FR and how they've all come together, synthetics and non-synthetics, natural fibers and treated fiber, etc. We don't know how they all interact, so we've categorically said, hey, if you're wearing this base layer and you're wearing this outer layer, go get it tested, then you know. So that all sounds great. What do we need to now look at? Which base layers are right for me? Okay, you see a picture up here of a short sleeve base layer and a long sleeve base layer. Which one is right for you? Well, a couple things to think about. If I want the benefit of the layers, meaning that if I want to, my outer layer is, say, an 8, my base layer is a 5, and when they're tested together, they're 18. My jeans are 18. Now I want to have an 18-calorie system, right? Can I have that with short sleeves? The general answer is no. It's not a system because where that outer layer goes from just above the elbow down to the wrist, it's a single layer. So your system is whatever your outer layer would be, and in my example, it was 8. So that's 18. Those two fabrics together are 18, but guess what? Your system is still an 8 because the lowest ATPV is in that single layer. So on the right there, you would have an 18-cal system based on that scenario I just described. If I throw an 8-cal shirt over top of this, and when they were tested together, they were 18 calories. My jeans are 18 calories. With this long sleeve base layer, I have an 18-calorie system. Now, where could this, depending on your hazard assessment, depending on your training, could I have a short sleeve implemented and still take the benefit? Yes, you could if you were a rubber sleeve utility. By putting the rubber sleeves over top of that, you cover from shoulder down to fingertip. Your system then would be chest down. You wouldn't need to be thinking about the single layer because your primary protection is going to be those rubber sleeves. That would be the only way you could possibly say that we would implement a short sleeve base layer and still get the benefit of the tested results at 18. I've heard that argued. Again, I'm not really sure where I sit on it, but I understand what they're saying. I get it. If you wore those sleeves every time, all time, and you wanted to take advantage of that layered system, I guess you could that way. The right way to do it for 70E and the right way to do it for utilities would to put a long sleeve over top of your long sleeve base layer here, and then you would get what truly is intended, the benefit of the system. How do you know that? Well, a couple things to think about. One, it has to be like product over like product, or an independent third party has to come in and tell you what those test results are. Why? Bulwark is going to test over Bulwark. Carhartt's going to test over Carhartt. Glenguard over Glenguard. Go down the line. We're not going to mix and match manufacturers and provide test results. It just doesn't happen. Bulwark has done about 150 different combinations of our stuff. The other top folks that I talked about all have their stuff tested out. It's very, very popular nowadays, and for the most part, if it's like material over like material, you're going to be able to get a relatively easy answer. If you're mismatching manufacturers, for example, you have Bulwark over Dry-Fire, NSA over top of Carhartt, you're probably going to have to look at a third party to get that testing done for you, and then you would know what it is. Another thing to keep in mind. I am showing you pictures here of shirts over shirts. Most folks think about layering as putting another shirt over top of another shirt, and that is how we think of it. But remember, these are fabric tests. I'm showing you a shirt over a shirt because that's how most people are going to implement it. I have a 6.3 ATPV over a 6.4 ATPV, and I have a 24. Your system's not 24. What is your system? Your system is going to depend on what your pants are. Your system is going to depend on what the lowest ATPV in that system is. That's what you're going to be your system is. If you have a 12 cal pant in that scenario, you have a 12 cal system, not a 24 cal system. That's a little bit on layering. Tips for use and training. Obviously, when we select the proper FR and when we start putting these systems and these layerings together, we want to make sure that we train our people. In fact, the regulations and the standards all require that we train and document on PPE. So 1910-132, you can generalize that and call that our PPE regulation. That's where they talk about training on PPE. And guess what? Flame-resistant, arc-rated clothing definitely is PPE. So we have to train on folks when it's necessary. What PPE is going to be necessary? How to properly don and doff it. That's our fancy way of putting it on and taking it off. The limitations of PPE, what it can do, and most importantly, what it can't do. How to properly care and maintain your PPE. What's a useful life, and then once the useful life is over, how do you properly dispose of your PPE? Think about things that we do all the time. Fall harnesses, when we get rid of them, we make sure we cut them up. Gloves, we make sure we cut the fingertips off. For FR, we recommend, in our case, you take the triangle, cut those off. Put a hole in that so that people can't go out and reuse it once you've that useful wear life is gone. Then we have to, each employee has to demonstrate that they understand what we're training them, and we have to document it, and we have to do all the appropriate things that way. So some just real simple do's and don'ts. When it comes to flame-resistant arc-rated shirts and pants, this is what y'all are supposed to look like. Okay? Tuck them in, roll them down, button them up. Remember, we said when it comes to implementing that PPE, a couple things you had to do. One is you had to have it, and then two, you had to be wearing it properly. Okay? You know, your fall harness does no good if it's not all cinched up. Your respirator is no good sitting on top of your head. Your safety glasses are no good sitting in your pocket. Your hearing protection, no good wrapped around your neck. all those common sense things that we talk about in PPE all apply to our clothing also. This is what I see, though, when I go out in the field. I see sleeves rolled up. I definitely see stuff untucked. And depending on where we are in the day and how hot it is and humid it is, I may even see them unbuttoned. Little things to think about. You've invested, in some cases, tens of thousands of dollars in your PPE, tens of thousands of dollars in your flame-resistant arc-rated clothing. What are a couple things that could trip up all that investment? Little things that folks don't normally think about. What do you put on your head? You have a perfectly sound flame-resistant arc-rated clothing program, and it's hot or it's cold or I'm sweating, and I put something underneath that hard hat or on top of my head that does not have the same flame-resistant properties, I have just jeopardized that whole program. That thermal event may ignite that, worst case, melt it to my head. Our brain is very, very sensitive when it comes to increases of heat, and I melt something to my scalp, very, very nasty outcome can happen there. Take a look at this very expensive flame-resistant arc-rated brown duck coat, and now I see this hoodie sitting out over the top of it. Well, if you remember our standards and our regulations, the outermost layer has to be flame-resistant arc-rated, so that hood just became the outermost layer. Is that hood flame-resistant arc-rated? Or did I just put my 65-35 hoodie on underneath, or my 100% cotton hoodie underneath, or what is that? I don't know, but if it's not FR, that's a big hunk of fuel you got sitting on the back of your neck. When you turn away from that arc flash and expose it to all that energy, it could ignite, and then you've just jeopardized that whole program. So wear the correct base layers under your FRAR garments is important. Make sure that you wear it properly, equally important. If you're going to incorporate layering, you can benefit from two lightweight layers, in many cases being far more protective than one heavier weight layer. Many folks spec Cat 2 garments today. They could easily implement a Cat 1 outer layer and a Cat 1 base layer, and they could have more protection than they could ever get from a single layer Cat 2 garment. So just some things to think about as you're going through that. FRAR base layers take away the potential for ignition when that non-FR undergarment gets exposed to any thermal energy. Remember, that outer layer is susceptible to failure. It is designed to withstand a certain amount of energy, and after that, you are exposing what is underneath. And then obviously, like we talked about, monitoring what you're wearing underneath, monitoring what your crews are doing. All the top manufacturers today when it comes to base layers, and I'm not just talking about ours, but if you look at that collar, you are going to see an indicator, a logo. That logo is an easy eyeball down the line to see if your guys have the appropriate undergarments on. Now, I can't stop them from cutting the sleeves off and turning them into tank tops underneath and taking away that benefit of the sleeve or anything like that. But I can take away whether that white V underneath there is indeed 100% cotton or 80-20 or 50-50 or some other combination. And I can definitely take away the fact that we're not going to give it to you with a big logo on the front, which could be heated up and impregnated into my skin during an arc flash event. So it's essential now that you've taken all these things into consideration. You've taken into it selection, you've taken into specification, you're taking into training. Now, how do you maintain this stuff? Proper care and maintenance of all your PPE is going to add to its wear life. It's going to make it ultimately work better if it has to be used for what it's been built for. And what it's been built for is to save your life in an arc flash. So how do you care and maintain this stuff? Today's quality manufacturers' FRAR clothing is relatively easy to take care of. In fact, we provide you all the instructions necessary right there on our tags. You can always go to the manufacturer's website and download their safety and care guidelines. In fact, all the standards talk to follow the manufacturer's guidelines. They're relatively easy. So what are those? Again, there's nothing in the laws and there's nothing in the standards that tell you exactly what to do, but trust me, after 40-plus years of doing nothing but FR, there's really just a few things you need to remember. Don't use any kind of bleach or peroxide on your FR. Don't use any kind of additives that can build up over time and impede performance. That's things like starch and fabric softener. Wash them separately from your non-FR. Well, that's just good common sense with your work clothing anyways, bringing it into a home environment. Turn your FR/AR garments inside out. That's color retention. We know that one. And then, use liquid detergents, plain old detergents for the best performance. Avoid hot temperatures for shrinkage. And for tough stains, you can shout them out. You can still use your shout, rub them in there, soak them overnight, do things like that. Pretty easy, tumble dry on low settings. All the stuff that, that you were taught back when you were a kid and how to take care of clothing, all that stuff still pertains. It's very, very hard to mess up the FR engineering in today's garments if you do these simple things correctly. The little image you see there on the right, that's a magnet we provide for folks who home launder. And that's kind of universal across manufacturers, those laundry guidelines. Like I said, there's nothing super fancy that you typically have to do. We always get asked about soiled garments. How much is too much? And when we're talking about soil, we're not talking about dirt. We're talking about secondary accelerants, oils, greases, fuels, etc. And if they stain the garment, well, if that garment on top and that garment on the bottom are stained, and they come back from either your laundry, the dry cleaner, or the laundry service, and they are clean, and they smell clean, and there's no smell of fuel, additives, or anything, then they are both fine. You have not done anything to the FR properties. Now, if they come back from cleaning or you pull that out of your laundry and you can still smell fuel, guess what it is? It's still fuel. If it smells like fuel, it's fuel. Launder it until it goes away. Don't wear it because that fuel byproduct will be burned off. And if you can't get rid of it, retire the garment. The next scenario is, if during my workday I get soiled with secondary accelerants when I look like this, if I'm the guy on the top, get me out of harm's way. That is way too much secondary accelerant. That hot spot in an arc flash would be huge. Everywhere where you see secondary accelerant is going to flare up, and that fuel is going to be consumed before it self-extinguishes. You do not want that big a hot spot on you. So get away from harm's way, either change out the garment or you're done for the day. The one on the bottom, that's probably reasonable to live with throughout the day. The hot spots would flare up. The surrounding fabric is significant enough and viable enough that it would put itself out. You'd have some minimal flare-ups, and that's about it. Repairing or replacing, and this is always tricky because there's no hard and fast guidelines to repairing and replacing FR clothing. Now, when they ask us as manufacturers, what do we recommend? Our rule of thumb is 3 inches and a nickel. If the hole is bigger than a nickel, don't fix it, replace it. If the tear is longer than 3 inches and not on a seam, replace it, don't repair it. Top left, those are thread-borne elbows. Those cannot be repaired. That is the base fiber underneath that you're seeing showing through there. Replace that. The one in the middle, on the thigh, that is not on the seam. That's irreparable. Also, the combination is far greater than 3 inches. Now, the one on the left, that's on the seam. That's greater than 3 inches. Can you repair it? You're in that gray area. It's on a seam. If I'm using Nomex thread and I'm using like materials, yeah, I guess you technically could. The one on the far right here, the shoulder there, that's probably 3 inches. That's on a seam. That's probably repairable. My rule of thumb when I'm talking to folks is don't repair it. I mean, think about your PPE, especially your clothing, the way you think about your fall harness. You wouldn't have a fall harness that has cuts, that has frays, that's ill-fitting, etc. You wouldn't climb a second in a fall harness like that. don't take your ARC-rated FR clothing into the field looking like this, and even repair it. My recommendation is replace them. So a couple things to think about. Inspect your garments daily. Check for holes, rips, and tears. When you pull that shirt and pant out of the closet, just don't put it on blindly. Lay it down, do a quick run through top to bottom, front and back. Make sure you've got no rips, tears, or holes in your PPE. Check for areas of heavy wear such as elbows, knees, fabrics that may be worn thin. And then check for the integrity of your seams. Those are going to be the high stress areas. Those are the areas that you're going to want to not fail during a thermal event. And as I said earlier, check them the same way you would check your rubber gloves, same way that you would check your fall harnesses and your other PPE that you implement into the field. Simplifying care and maintenance. Flame-resistant arc-rated clothing, always appropriate to the hazard. Always the outermost layer. Remember that picture we showed you with the hoodie on the back. At the very minimum, always natural, non-melting undergarments. Clean, no flammable contaminants even throughout the workday, and definitely make sure they're clean when you're taking them out of the wash and implementing them into the field at the start of the day. Repair correctly and remove from service when needed. Always, always wear it correctly, zipped up and buttoned. The picture on the right, unfortunately, that was a verification error. Failure to verify the absence of voltage. We went in and turned off the piece of equipment, came back, rolled up the sleeves of our perfectly good arc-rated shirt, because you can see where it was rolled up to and where it performed. We took off our rubbers and leathers, and we proceeded to do what we thought was de-energized work. As you can see, it was not. This little safety tag here goes on all the hard hats of a number of utilities that I've visited, and it simply says button, tucked, and rolled to remind the guys how to properly implement their PPE on a day-to-day basis. Just a real quick bonus, and we're getting right up here on Q&A time. Think about outer layers. Think about your rain gear. Think about your high-vis vests. A lot of utilities today and a lot of our electrical guys are being required to have high-vis safety apparel, and then when we put them out in the rain, they're required to wear rain gear. Guess what? That rain gear is now the outermost layer. That rain gear has to be tested to the hazard. In this case, it has to be ASTM 1891 for arc flash, ASTM 2733 for flash fire. At the end of the webinar, if you're responsible for rain gear, if you have rain gear in your program, make a quick note to go down and check your tags. Make sure it's ASTM 2733 or 1891 accordingly, or better yet, it has both in there. Any other standard, and especially any standalone standard for your rain gear, for example, ASTM 6413 is popular standard for rain gear. As a standalone, it is meaningless. It is not a performance standard. It's the vertical flame test. It should be the predecessor to a whole bunch of other tests before you ever wear it in front of a hazard. Many flame-resistant rain gears are marketed as such by passing just that one test. It's not a performance standard. You have no idea how that rain gear is going to perform in your hazard. An easy way to determine if you've got the right rain gear, if your rain gear cost you $100, you all got the wrong rain gear. If your rain gear costs you closer to $400, $500 and it's been tested at a hazard, you've got the right rain gear. The other thing to think about now is we've got a lot of companies that are adopting FR vests, especially ANSI 107 2015 compliant vests. Read the labels. Make sure in that label it tells you that ASTM 1506, that's how it became FR, and you've got an ARC rating in that label. If it doesn't have an ARC rating, if it tells you some silly things like it self-extinguishes, but there's no ARC rating, there's no reference to 1506, wrong vest. We see vests that are compliant to an NFPA 701 standard. That's not even a garment standard. That's a drapery linen standard for the hospitality industry. It's a topical treatment in many cases, and it should not be what your vest is compliant to. You want your vest to be compliant to 1506, 2733, 1891. It can actually be NFPA 1977, which is wildland. That's one of the ones that ANSI allows you to be also, and also NFPA 2112. But if you have any doubts about your rain gear or your vests, take a picture of it, you'll have my email contact information. Shoot me an email, and let's make sure that we're not jeopardizing your program and, more importantly, your people's safety because they think they're wearing the right thing, and in reality, they're not. So real quick, just wrapping up here for you, a couple points I always like to get to folks who are selecting, using, care, and maintaining their flame-resistant arc-rated clothing program. When looking for folks, ask for manufacturer's guarantee in writing on letterhead and get a signed copy of it. Make sure that that guarantee is not tied to any standard, meaning that it's guaranteed to meet ASTM 15 sticks, guaranteed to meet whatever. Make sure it's guaranteed for life. That garment is guaranteed to be flame resistant, arc rated for the life of that garment, and that's the useful life of the garment. Ask for the test data for your hazards and then verify the test data. I can't tell you how many times I've seen certificates that folks have gotten and we've went to verify it and they're inaccurate at the very least. Ask to see the certifications, every garment that's been tested for your hazard. Just because they have one garment that meets your hazard doesn't necessarily mean all their garments do. Specify that only certified compliant garments are allowed on your site. Periodically police your program for compliance. Doesn't have to be every 6 months, but you know, every year or so, just go out there and do a quick audit, make sure nothing's snuck in the door. And then lastly, work with proven supply chain partners. Now, this is key in a very sensitive area. All flame-resistant arc-rated clothing, if it's not used in the hazard, is just really expensive soil protection. When do you know where corners have been cut? Unfortunately, you're not going to know where corners have been cut on any manufacturer's garment until they are implemented in the hazard they were designed to protect you against. That's where you will find they fall short. So work with proven supply chain partners. Work with folks who have a history, a go-to-market proven strategy, have been bought for multiple sales cycles, and only use proven, viable fabrics and components in putting their stuff together. So with that, I'm going to turn it back to Ed for Q&A. If we don't get to your question today, the good folks will make sure that in a couple days I'll get all those questions. I will get your question answered or get that answer to your question back to you at some point. So with that, Ed.
Thanks, Derek. Looks like we have a little more than 10 minutes for Q&A. Just a reminder to our attendees, you'll need to open the chat module to ask your question. You might have to move your mouse down towards the bottom center of the screen for the speech bubble icon to appear. You click on that and then your chat window will open and you can type in and hit enter and we will get your question. Derek, first question here is from Paul, and just a second, let me get the right document here. Okay, Paul asks, in the context of arc flash evaluation, can you please explain in more detail what is meant by the abbreviation MCC, Motor Control Center, and DB Distribution Bus?
Well, I hate to start out by answering the first question as you have just went outside my area of expertise. I am not an electrician. I am an FR Clothing guy. That's where my expertise lies. But I'd be happy when we get that question to direct you to someone who would be able to combine both their electrical expertise and their FR knowledge and maybe give you a better answer.
Okay, thanks, Derek. Paul is also asking if you were going to be discussing FR standards too, including ASTM E3082 and NFPA 701. Now, I do know you mentioned 701 towards the end there.
701 for us, we don't delve into because that's like I said, that's a textile drapery / linen standard. It's not a garment standard. ASTM 1506 is really the big one for us. Within that, we have ASTM, the test methodologies like 1930 for flash fire, 1959 for arc flash, and those are the ones that we focus on. So I could definitely get more information offline to Paul about that.
Okay. Richard asked a question, are there standards specific to testing of cooling garments that can be used under Cat 4 suits, for example? Are all components of a cooling garment used under a Cat 4?
I can speak to just a very small portion of that. Salisbury, who's now under Honeywell, they did put together a cooling fan system, and I believe it is still available for their suits, as does Oberon, and all those materials that go into protecting the fan, the generation system, all those covers and flaps from those manufacturers, I do know are all tested and meet the standards for those. But again, you have to be cautious, and you have to work with proven folks who have done this over time, and those are two that I know that have spent extensive times looking at cooling folks down inside Cat 4 suits especially.
Okay. DITA has a question. She asks, I often see that although there is an arc flash label on the electrical panel, my contractors generally use infrared camera and in some circumstances don't even have to open the panel. Do we still need to enforce the FRAR clothing?
Good question. I would direct you right to 70E. They have a specific section in there, and I could dig down and find it and be able to get that to you on thermography and exactly what's required. And obviously, from a thermographic standpoint, from an FR clothing standpoint, are we looking at the shiny parts? Are we opening stuff up? Are we taking panels off? Are we exposing the thermographers to the energized equipment? Are they in the arc flash boundary? And as you step through that, it can be maybe. It depends on how close I have to get. It depends on where that arc flash boundary extends to. It depends on whether or not I'm having to open the doors and look at things. There's a lot of variables in there. So I know myself and others, I would default to at least a minimal level of arc-rated clothing to ensure that if anything did go wrong, that I have a minimal level of protection, at least on those folks. I definitely wouldn't be doing that task in 100% cotton, regardless if it said I was allowed to or not. So that's kind of where we look at the standards as a bare minimum. This is what we want to at least get to, and can we go beyond that? Well, yeah, because we're taking pictures of something that we may think something's going wrong on, and we may be looking at that to see if there's something occurring that we can't see. Well, we technically could be potentially in harm's way. And if we pick that time when everything just comes together, and I don't know, in my opinion, I say you at least go to what you would do for an electrician that was in the arc flash boundary, whether there were thermographics or not, whether things were open or not. If I was technically there, I would definitely get them at least in the same as my electrical workers who were entering the arc flash boundary.
Okay, this is a question from Robert. He asks, do you have any thoughts on FR disposable coveralls, not arc flash rated, but worn over the top of arc flash rated clothing? And he refers to the standard ASTM F1930.
Yes, good question. So if you are, again, if you're wearing a disposable coverall, the intent or the design of that disposable coverall, whether it's a flash fire exposure as in 1930 or an arc flash exposure as in 1959, that really that soil protection, because that's what you're wearing it for. You're wearing it to protect the greater investment. So I've got a couple $100 worth of AR clothing on, and I go and put on a $20 disposable so that I don't really get this one all dirty. In a thermal event, that outer layer, that thing is flame resistant. That means it will not ignite and continue to burn. That means more than likely it's going to be gone. Whether that's a flash fire or an arc flash, those are very thin. They're designed just not to ignite, and they are going to be basically, they're going to disappear in the very first nanoseconds of that event. So then what's doing all the work is what you're wearing underneath, and that should be your daily wear. So if you implement it as the question was stated, over top of my arc-rated clothing, over top of my flame-resistant clothing that I've already determined is enough for the hazard, then that's just soil protection that's not going to ignite, burn, and add to the injury, and they're designed basically to disappear in those types of events. So yeah, if you're wearing it to protect against soil and it's not going to ignite or burn, that's how I would implement it.
Okay. Sharon asks, if properly laundered, how many washes to maintain the FR rating?
Great question. And it's interesting because with all the years we've been doing this, I probably fielded that question back in 1990, and I'll continue to field it every single time, regardless of what we talk to as far as the FR engineering today is. And I'll talk to Bulwark, and I'll also give you a caveat of saying the top manufacturers today in flame-resistant arc-rated clothing, the fabrics that we're utilizing today, the engineered FR properties, and that's what we're talking about there is the ability to self-extinguish, whether it's in an arc flash or a flash fire. Those FR properties are very, very difficult to impede, almost impossible today to remove from top manufacturers. That means, to answer that question, it's not laundry dependent. It doesn't matter if you wash them 20 times or 120 times, they are going to perform as they were designed to perform, and that's self-extinguish in a thermal event. So the degradation of FR technologies in today's proven fabrics is pretty much very, very hard to do. That's why we say no peroxide, no chlorine, don't put any fabric softener or starches on it. Those are the biggies. You stay away from those, and you just launder them. As long as they're good and wearable, they'll last, and the FR properties are going to be there. You do not have to worry.
Okay. Chris has a question about a concern that he hears a lot from employees. He asked if you could discuss the cleaning of contaminants, for example, washing at home versus using a service. Can other family members, if they're being washed at home, become contaminated?
Good question. And here, let me I'm going to split it up a little bit. And contaminants. What are you bringing home from the job site? That's what we're going to talk about as contaminants, because as far as the FR technology, the FR engineering, what imparts those FR properties, whether it's at the molecular level, the fiber level, or the fabric level, those are not laundry dependent in the sense that there's any byproducts coming from those. So the contaminants that we're going to talk about here is what you're bringing from your job site. If you have concerns that you're going to bring contaminants home, and even though you're washing these garments separately, that any residuals are in your residential washer and dryer, that would be concerning, yes, and that's legitimate because I don't know what's on your job site. That's where industrial launderers can partner with you and provide a value-added service in the sense that the peace of mind that, hey, I put this in a separate container, it gets picked up on a weekly basis, it goes to an industrial launderer, which is 20 to 30 degrees hotter water than I can do at home. They have special processes in which I may or may not have access to at home, and then they can give me the peace of mind that this is one way of laundering my garments versus if I have 100 employees, I could potentially have 100 variables in my laundry process. So there are advantages to having an industrial laundry when you start thinking about what am I taking home to my family. So I don't want to say that it's not legitimate, because it is, because I don't know what you have in your work environment that you could potentially take home. I definitely don't want you to be concerned that you're taking something home in and of itself in the FR chemistry or the FR engineering, because you're not. Does that make sense?
I think so, Derek. Unfortunately, we're out of time. I'm sorry to those of you whose questions we didn't get to, but Derek's contact information is in the chat window. He'd be happy to respond to you when he can. I'd like to thank Derek for your presentation today. Also thank Bulwark Protective Apparel for sponsoring today's webinar, and to all of our listeners, please be on the lookout for announcements of upcoming Synergist webinars.